Hello students, today we are doing lesson 5.7 and that's on absolute value inequalities. So we're going to do a quick remember how to do inequalities. So before when we had just equal signs and we would say the absolute value of x equals 3, this meant that x could be 3 or it could be negative 3. Okay, well I should say and or because it can be both, okay? So we always had two answers with absolute values. And that's because when we do the absolute value of 3, that equals 3. But the absolute value of negative 3 also equals 3. So remember the definition of absolute value is how far something is the distance from 0. So distance can't be negative, okay? So that's why our answers were both 3 and negative 3, because those are both 3 units from 0, okay? This is going to be important in a minute for what we're going to do next. So now we're going to do absolute value of inequalities. So we're not going to have equal signs. Now we're going to have absolute values, inequality signs. So let's start with an example. Example 1. It's going to be just like what I just did with the equal sign, but we're going to do it with an inequality sign. So we have the absolute value of x is less than 3. Okay, so instead of teaching you how to do this, I'm going to kind of explain it a little bit differently. We're going to check some numbers to see if this is true, and we're going to write whether they're true or not. Okay, so is the absolute value of 5 less than 3? No, because the absolute value of 5 is 5, and 5 is not less than 3. Okay, how about the absolute value of 2? Is that less than 3? Yes, it is. Okay, and because the absolute value of 2 is 2, and that is less than 3. Okay, how about the absolute value of 0? Is that less than 3? Yes, because it's 0. Okay, absolute value of negative 2, is that less than 3? Well, the absolute value of negative 2 is positive 2, and yes, that is less than 3. Okay, one more. What about the absolute value of negative 5? Is that less than 3? No, because the absolute value of negative 5 is positive 5. Okay, let's say positive 5, and that is not less than 3. Okay, that one does not work. Okay, so let's look at what the solution to this is on the number line. Okay, so I'm going to go 1, 2, 3, 4, 5. I'm going to go all the way up to 5 because we did all the way up to 5 on the examples. Okay, and then I'm going to see which ones of these were true. Okay, so I'm going to erase this in just a minute. We said that 2 was true, 0 was true, negative 2 was true. Okay, let's just check 3. Would 3 be true? If I had the absolute value of 3, is that less than 3? No, that is not less than 3. But 2.9 would be, right? 2.9 would be less than 3. So I'm actually going to have all the numbers that are between 3 and negative 3 are all answers, right? The other ones that are higher than this or outside of this, let's say that. So all the numbers all the numbers here and here are not going to be answers. Okay, so how would I write that answer down? Well, we learned this when we did conjunctions and disjunctions, right? So to write this problem, I would have negative 3 is less than x, which is less than 3. Okay, so really you read this saying x, you always say the middle first. X is greater than or equal to negative 3 and less than 3. So this is my answer for that graph. Now, we're not going to do graphs all the time. That was just to kind of show you how to do example 1. So let's work on example 2 without graphs and without writing all those yeses and nos. So if I have the absolute value of x is less than 5, okay, so remember this means the distance before it gets to 5. So the way we're going to do this is if I had the absolute value of x equals to 5, we would always do 2, right? A positive 5 and a negative 5. So we're going to do the same thing over here on the inequality. We're going to take out those absolute values and just say x is less than 5, but it's also x we're going to put a -5. But instead of writing less than, I'm going to flip my sign. Okay, and if we were in class, I would say, why do we have to flip the sign when we change it to -5? So usually I get lots of kids answering that and trying to figure that out. And somebody will say it's because we multiplied. Wait, let me write that as a times. We multiplied by a -1. And so when we multiply by a -1, we flip the sign. So if you're going to change the 5 to -5, you have to flip the sign to be greater than. So now let's take both of these and write it as a conjunction. So we have x in the middle, right? And then -5 is going to go on the left because we go the least numbers on the left, and +5 is on the right. And there's my answer. I didn't have to do much. We'll do a harder one in a minute that has more than one step. Okay, so that was example 2. All I did was write out both of the problems with, right here, one with +5 and one with -5, and then I put it into a conjunction. Okay, next one, example 3. Notice I'm using Christmas colors because it's getting close to Christmas. Okay, now I have the absolute value of x is greater than 1. So this time I have a greater than sign. If I look at a number line and thought about numbers that were greater than 1, okay, here's 0, 1, 2, 3, -1, -2, -3. If I look at ones that are greater than 1, it's going to be over here, right, on this side. And I would have to look at -1 also because, whoops, that's not what I meant to do. Okay, let's rewrite this like what I was telling you up here on this one, okay, is I am going to rewrite it as x is greater than 1, and then when I do rewrite it as -1, I'm going to flip that sign. Okay, so now I have 2 problems right here, but they are not a conjunction because if I graph these, if I graphed both of these, I have x is greater than 1, which is over here, and x is less than -1, which is over here. So let's put those actually on the graph, and when I do that, I get it looking like this. Okay, so that means I have a disjunction. So when I have to write this, I'm going to always start with the lowest one. So I'm going to use this one first. So I'm going to have x is less than -1 or x is greater than 1. And that's how you write the solution when it's a disjunction. Okay, don't try to write it like we did up here. Okay, it's a disjunction on a graph. So I'm going to write it just as an or. Okay, and that's it. So this may be pretty easy to solve, especially these easy ones. I'm about to do a 2-step one, but you have to be able to tell if it's a conjunction or a disjunction. Okay, so let's do another one. And one way that is easy to tell is if you have an x on the left. Always make sure you have an x on the left, which I think all your problems do today. Then it's the less than and the greater than are what's going to show you if it's a disjunction or a conjunction. So I'll show you some of these, some more examples to hopefully help you see that. Okay, example 4, I have the absolute value of x is greater than 6. So if I was doing a greater than 6, that means x is greater than 6 or x is less than -6 because I have to flip that sign. So if I'm looking at that on a number line, okay, I'm just going to do a quick one. You do not have to draw a number line every time, but this is just to show you. And I have x is greater than 6 or x is less than -6. See how it's a disjunction? They're separated. So this is my answer right here. Oops, except for that I want to rewrite it so that the least number, which would be -6, is on the left. So I'm going to have x is less than -6 or x is greater than 6. I'm not going to count off if you don't put the one on the left as the least, but I like to do it the correct way so that you can get used to seeing it that way. Okay, so now let's do one that has a two-step problem. So as you notice here, both of the ones that have greater than signs were disjunctions, and the two that had less than signs, where's the other one, were conjunctions. Okay, so that should kind of show you which way we're leaning here. Okay, example 5. We have 2 more problems we're going to do. Example 5 is the absolute value of x plus 5 is less than or equal to 10. So we have a less than. Okay, so that's probably going to mean that we have a conjunction, right? And we're going to write this out twice. We're going to say x plus 5 is less than or equal to 10. And then when we write it out the second time, we're going to flip that sign and make it a negative 10. Okay, so don't forget you're doing 2 separate problems. Okay, now I can solve this. I'm going to subtract 5. And I get, on this side, I get x is less than or equal to 5. And over here, I get x is greater than or equal to negative 15. Okay, now you can either do this in your head thinking, or you could draw a quick little sketch. It doesn't have to be perfect. It could just look like this. I'm just putting the numbers where they would be on a graph. And then I'm going to do the first one, x is less than or equal to 5. So it would be like this. And then the next one is x is greater than or equal to 15. So it would look like that. So you see how this is a conjunction because we're only going to graph inside. I kind of left out that circle. We're only going to graph, or we're only going to say this is the answer where they both are together. So in order to write that out, I put the least number here and then the greater number here. And that's my answer. So I have a conjunction. Okay. Hopefully this isn't too difficult if you were able to do inequalities okay. Okay, example 6. We're going to do the same thing. Negative 3x plus 6 is greater than 18. So I have a greater than sign. So I'm probably going to have a disjunction, right? So let's just solve it like we would if we were doing an inequality. We would have 2 problems. We would have negative 3x plus 6 is greater than 18. And we would have negative 3x plus 6 is less than negative 18. So remember, with inequalities, one is positive and one is negative. But on the negative one, we have to flip the sign around. Okay, now I'm going to solve this. So I have 2 steps on each of these. I'll just do them one at a time, though, not to confuse you. Okay, so I get negative 3x is greater than, let's see, we're minusing 6, so that's 12. Then I'm going to divide by negative 3. Okay, I'm dividing by negative 3, so I have to flip my sign. So now it's less than. X is less than negative 4. Okay, now I'm going to go over here and do the same steps, but I'm going to get different answers because I have a negative 18 on the right side. So here I get negative 24. Now I'm going to divide by negative 3. And x is greater than, let's see, negative 24 divided by negative 3 is 8. So now I have 2 different answers, okay? And I told you a little while ago, I told you that greater than is probably going to be a disjunction, right? So let's check that. Oops, I erased this. Let's check that really quick with a graph. So I'm going to have negative 4 over here, 0 over here, and 8 over here. Okay, this graph shows me the first one says it's less than 4, so that's going to go this way. And the other one says it's greater than 8. So you see how it's a disjunction? So with disjunctions, all you have to do is take these 2 and add the word or. So I'm going to have x is less than negative 4. Always make sure the smaller one is on the left. And or x is greater than 8. And that's your answer. That's it. Okay, that's all the examples I have for you. Hopefully you'll catch on to this. You don't have too many of these on your test, but but they're really not difficult if you can manipulate the equations right and make sure you're flipping your signs when you're supposed to. So it's a lot of flipping. Take your time and flip them when you're supposed to. You flip when you are making this number into a negative. You need to flip, right? And then the other time you need to flip is when you're multiplying or dividing by a negative. Then you flip the sign also. Make sure you flip both times if you have those things. Don't just flip it because you're like, oh, I don't know if I'm going to flip it, so I just need to flip it. Make sure that you're either changing a number to its negative, which you do at the very beginning, or you are multiplying or dividing by negative. Okay, that's it for today. Thank you.